Hello everybody and welcome to Everyday Leetcode, and this today we are going to solve another interesting problem. The problem is sub array sum equals k. Actually, I made this video and I'm remaking this video again because the sound didn't really come out right in the previous video. So uh, let's really again, let's go with the structure. Let's understand the problem, and then let's go with the logics. So what is the problem? The problem is you have an array an array of integers. The integers can be positive, negative, anything, and you need to find, and of course you are given k is some integer number. You need to find the sub arrays such that you need to find that the sub array sum up to k. uh, when the sub arrays are summing up to k, it's at that particular point you count your sub array in the answer. So you need to return the count of the sub arrays that add up to k, and sub arrays note must be continuous. So for an example, if you have 111 over here, if you look at the example here, 111 is there, and for 111, all right, mouse is not working. So for 111 you have two subarrays, that is this 1 plus 1 is 2, or this 1 plus 1 is 2. There is no other subarray that adds up to 2. So of course one naive solution would be have two for loops, start with I as 0 till the size of the array, and the inner for loop will be from j is equal to I plus 1, and you keep adding uh, adding the j values into your sum and keep checking. So basically find all subarrays, exhaust all the possibilities of the subarrays, and check if the sum is equal to 2. If it is equal to 2, add that to your counter variable. So that would be a naive solution, but that would take order of n square. But what we want here over here is order of n time, and so we need to basically order n time means we need to remove the inner for loop. And whenever you encounter a sum problem and whenever you want to remove an inner for loop, it's always the best solution, always occurs in a map. And because it's a sum problem, you can actually find, you can use the find function of the map, uh, because it's a sum problem. A plus b is equal to sum, so a is sum minus b or whatever, something like that, or b is equal to sum minus a. So that is the solution. Now if you simply go about the solution, let's try to understand how do you solve this. So before going on to that, let's understand how can I use a cumulative sum to get a subarray sum. So for example, if you have 1 2 3 4 5 6 7 8, something like that, 0 1 2 3 4 5 6 7, these are the indices. If I have the cumulative sum over here is 1, the cumulative sum over here at the first index would be 3, the cumulative sum over here would be 3 plus 3, which is 6. Here it would be 6 plus 4, which is a 10. 10 plus 5, it's 15. 15 plus 6 is 21. 21 plus 7 is 28. 28 plus 8 is 36. So the cumulative sum would sum up to this. But how do I utilize a cumulative sum? So let's say that you want a sum of a sub array starting at position 2. So you want, and ending at position 4. So you want 3, 4 and 5. So how can I utilize this particular thing. So what I can do is I can write at a of 4, a of 0 plus a of 1 plus a of 2 plus a of 3 plus a of 4 would be my cumulative sum. And since I require a of 2 plus a of 3 plus a of 4, I need to subtract a of 0 plus a of 1. So I can subtract the cumulative sum plus a of 1 at the position 1. So if I subtract it at position 1, I can get the cumulative sum in that fashion. So that's how you get a cumulative sum of a sub array in general. So now we know how do we get the sum, but they have given you the sum. So, I mean, they have given you what the sum should be, and you need to count the number of sub arrays, right? So what do? Is we take a map. There is a key in the map and there is a value in the map. And the key is actually the cumulative sum always, and the value is the number of times that cumulative sum is occurring. So for example, the cumulative sum of 0, the value has to be 1, has to be initialized, because an empty array is always a part of the subarray. So even an empty array is a subarray. So the key would be 0, and that means the cumulative sum would be 0, and there would be one empty subarray in every array. So that is why you have a 1. Now as soon I see a 1, what I can do is I will add this here, I will increment the count over here, and then I will check if sum minus k, sum is 1, so 1 minus k, whatever is my k can be 2, 3, anything. So let's walk through this particular example that they have given you. Not that example, but a better example. Let's take a better example, not their example. Let's have 1 year, let's have 4 years, so that counts up to 5. 5. So I have a 6 year, I have an 8 here. I'm just adding like any random piece of numbers. I have a 9 here. I can just add some negative numbers here. So 1 minus 4 would be a minus 3 plus 6. Minus 3 would be here, plus 6 would have been a 3. So I know it's a 3. So let's keep my key as 3. K is equal to 3. Now how do I walk through this? 3 is here, 4 is here, and 5 is here. So yeah, so you have a map here, you have a key, and you have a value. So what is the key? The key has to be 0. The value would be 1 initially. Now you find a 1. The moment you find a 1, you add that particular sum, and that value becomes 1. Since the sum minus k is equal to what? 1 minus 3, which is equal to minus 2. Check if minus 2 is there in your map. If it is not there, you just go ahead. It's not there, so I go ahead. Minus 4. So 1 minus 4 is a minus 3. So minus 3 is added, and 1. So your sum is minus 3. So minus 3 is equal to a minus 6. Check if there is a minus 6 over here. It's not there, so you move ahead. Then you have a minus 3 plus, minus 3 minus 8. All right. So minus 3 minus 8 would become minus 11, and you need to check minus 11 minus of minus 11 minus 3, which is equal to minus 14. It's not there, so you simply add your minus 11 into the map. Minus 11 into the map with a value 1. Now you add a 3 to the cumulative sum, so it's minus 11, so minus 8, so minus 8 is added to your cumulative sum. So now minus 8 is added to the cumulative sum. Now you check minus 8 minus 3, which is nothing but minus 11, if it is there or not. Yes, it is there. So you increment your answer by 1. Answer is incremented by 1. So what I have over here is this. Answer is incremented by 1. Yeah. So whenever I find this value, so whenever, basically what I'm trying to say is keep on finding the cumulative one, and whenever I find something like some minus k in my map, some minus some minus k in my map is present in the map, it means that there is a sub array that sums up to k. Okay, so for an example, if you had this minus, so basically that if you take the cumulative sums this way, and what exactly you are trying to do is, so let's take a simpler example again, 0, 1, 2, and this is your map, this is your key, this is your value over here. Of course 0 would always be 1. When you find a 1, you add it here and you check if 2 minus 1, okay, k is equal to 2. Check if 1 minus 2 is present in the map. It's not present in the map, move ahead. The cumulative sum becomes 2, the value is 1. Is s minus k, that is the sum minus k, is equal to 0. Is it present? Added by the value, so the answer becomes 1. Now you move ahead, the cumulative sum becomes 3, the value becomes 1. Now 3 minus 2 is equal to 1. So check if it is there in the sub. Yes, it is there. So it is, so 1 was a cumulative sum at which index? At this index. So if I remove all of this from this to behind the cumulative sum, if you just remove all of that, what you have this sub array. So this is what it means. So that is why I always check sum minus k. So that is how I solve this problem. And basically it's very important to understand the logic. And if you want to walk through the code, let's just walk through the code once. So I just created a hash map of and then I made hash of 0 is equal to 1, because that's a base case, that's a basic thing, that every array has a subarray of length 0, and that's an empty subarray. Sum is equal to 0, count is also equal to 0. When I go from I is equal to 0, I less than a dot size, that's just iterating to this thing, and this is the cumulative sum that I find. If there happens to be so if I find some minus k to be greater than 0, so it means that I found an element that so sum minus k, I have found the sum minus k. If I find the sum minus k, I increment the count by the value of sum minus k over here, and that's what we were actually doing in the example also. If hash dot find of sum is not equal to hash dot end, then I increment the sum. That's just trivial. It's just finding that particular sum and incrementing it, and else I simply insert the sum, because I did not find that particular sum, that cumulative sum in the hash map, so I added. That's what I did in the example. So that's all for today. Thank you.